Now let us look into some of the problems as related to the first chapter, that is Introduction to Signals and Systems. The problems include some of the previous questions from gate papers, and they also include some general problems. The first question is, there is a signal x of n given. X of n is equal to minus 1 by 2 whole power n u of minus n minus 1. You have to find if the signal is energy signal. So the signal is energy signal if the energy of the given signal is finite. That is, it should be between 0 and infinity. So for this, first we find the energy of the given signal as Ex is equal to sigma n equal to minus infinity to plus infinity mod of x of n whole square. This can be further written as sigma n equal to minus infinity to minus 1 by 2 whole power 2n. This is the case because x of n is present only in the range minus infinity to minus 1. Hence, the range is modified for summation. This can be modified as sigma m equal to 1 to infinity 4 power n, which tends to infinity. From this, as the given energy of the given signal is not finite, the given signal is not energy signal. Now let us consider another problem, that is, there is a signal x of t given, that is equal to sine square of 2 pi t. We have to find if the signal is power signal. The given signal would be power signal if its power is finite, that is, power of the signal should be between 0 and infinity. Alternatively, we can also, if we are able to prove that the given signal is periodic, then also the signal is power signal. This is just a sufficient condition and is alternative to proving that the power of the given signal is finite. So, for the given signal can be written as x of t equal to sine square 2 pi t, which can further be modified as 1 plus cos 4 pi t divided by 2. We see that from this the given signal is periodic with a period of 1/2 second. From this we see that the given signal is periodic, hence the signal is power signal. Now let us consider another problem, as per which there is a system given as y of t is equal to x of t minus 1. This is for t less than 0, and it is x of t. This is for t equal to 0. It is x of t plus 1. This is for t greater than 0. We have to find if the system is linear or time invariant or causal or stable and has memoryless properties. Now we know that the given system would be linear if it satisfies superposition principle. We can prove that the given system satisfies superposition principle. From this, we can definitely say that the given system is linear. We can say that the given system is time invariant if it satisfies the property y of t minus t naught, that is the delayed version of output is equal to the output due to delayed version of input, that is transformation of x of t minus t naught. From the given system we can say that this property is not satisfied due to the nature of the system, that it gives different outputs or different, it has different output equations depending on the value of t. From this we say that the given system is time variant. Also we see that the system output y of t depends on future x of t. This is for t greater than 0. From this we see that the given system is non-causal. As the system is non-causal, we can definitely say that it has memory, and also we can prove that if we assume that the input is bounded, that is mod of x of t is less than or equal to bx, from this we can prove that mod of y of t is also less than or equal to bx. So from this we can say that the system is stable in VIBO sense. So the given system is linear, time variant, non-causal, has memory, and is stable in BIBO sense. Now let us consider another problem, that is there is a system there is a system that is given as y of t is equal to x of t plus x of t plus 2. We have to find if the system is linear, time invariant, and causal. We can say that the given system satisfies superposition principle. From this we can say that the given system is linear, and also we can prove that y of t minus t naught, that is output, the delayed version of output is equal to the output due to the delayed version of input, that is t of x of t minus t naught. So from this we can say that the given system is time invariant as well. We also see that the y of t, that is the output, depends on future x of t. From this we see that the given system is non-causal. So as the system, from the above we see that the given system is linear, time invariant, and non-causal. There is a signal x of t that is given as x of t is equal to 1 plus sine of 100 pi t as a whole multiplied by cos of 200 pi t. We have to find the time period of the signal x of t. For finding the time period of the given signal x of t, we can simplify x of t as shown, that is x of t is equal to cos of 200 pi t plus sine of 100 pi t multiplied by cos of 200 pi t. This can further be reduced as cos of 200 pi t plus 1 by 2 as a whole multiplied by 2 sine 100 pi t multiplied by cos 200 pi t. We know that sine of a plus b minus sine of a minus b is equal to 2 cos a sine b. From this we can return the give up we can further simplify x of t as cos 200 pi t plus half multiplied by sine of 300 pi t minus sine of 100 pi t. So for finding the time period of the given signal, we have to find the time periods of cos 200 pi t, sine 300 pi t, and sine 100 pi t. We know that the time period of cos 200 pi t is 1 by 100 second, and the time period of sine 300 pi t is 1 by 150 second, and the time period of sine 100 pi t is 1 by 50 second. From this, we can say that the time period of x of t tx is equal to LCM of 1 by 100, 1 by 150, and 1 by 50. From this, we can show that the time period of the given signal is 1 by 50 second, as 1 by 50 is the least common multiple of the obtained individual time periods. So time period of the given signal is 1 by 50 second. Now there is a discrete time system that is given as y of n is equal to e power x square of n. We have to find if the system is linear, time invariant, causal, stable, invertible, and also if it is memoryless. We see that the given system doesn't satisfy superposition principle. From this, we can say that the given system is nonlinear. We can also see that the given system satisfies the condition y of n minus n naught is equal to t of x of n minus n naught, that is the output due to delayed version of input is equal to the delayed version of output. From this, the given system is time invariant. We also see that the output at any n depends on the input at that instant. That is, it depends on the present input only. From this, we can say that the given system is causal. We can also say that the given system is memoryless. We can also say that for any bounded input mod of x of n less than or equal to bx, we can say that mod of y of n is equal to mod of e power x square n, which is less than or equal to e power bx square. As bx is finite, e power bx square will also be finite. So this would definitely be less than, sorry, this could definitely be equal to by, which is finite. From this, we see that for a bounded input, the output is also bounded. From this, we can say that the system is stable in BIBO sense. Finally, for invertibility, we can write the given transformation as x square n is equal to log of yn. This can further be reduced as x of n is equal to square root of log of yn. From this, we see that the given system, given any input x of n, we get a output y of n, and from the obtained y of n, we can get x of n back using the equation x of n, or using the transformation x of n is equal to square root of log of yn. From this, we see that the given system is invertible, and the inverse system of the given system is x of n is equal to square root of log of yn. There is a discrete time system which is represented as y of n is equal to sigma m equal to 1 to n f of m multiplied by x of m. This is for n greater than or equal to 0 and y of n is 0 otherwise. We have to find the value of f of n for which the given system would be stable. This f of n that we have to find out, or it should be chosen from the four options that are given. The four options given are: the option A is n into u of n, option B is e power n multiplied by u of n, option C is sine of omega naught n multiplied by u of n, option D is e power minus n multiplied by u of n. We know that the system, for the system to be stable, we have to prove that the system would be stable in BIBO sense. So for it to be stable in BIBO sense, if mod of x of n is less than or equal to bx, then we have to find f of n such that mod of y of n is less than or equal to by, where bx and by are finite. So by assuming that x of n is bounded, that is mod of x of n is less than or equal to bx, we can see that mod of y of n is equal to sigma m equal to 1 to n f of m multiplied by x of m. We know that this is less than or equal to sigma m equal to 1 to n mod of f of m multiplied by mod of x of m. But we know that mod of x of m is less than or equal to bx. From this, we can show that this is further less than or equal to sigma m equal to 1 to n mod of f of m less than or equal to, sorry, multiplied by b of x. But for the system to be stable, this should be less than or equal to by. From this, we can show that the given system would be stable if sigma m equal to 1 to n mod of f of m is less than or equal to b. So, if this condition is satisfied, we can prove that the given system is stable. And also, please note that this condition should be satisfied for every n. From the options, we see that options A, B, and C don't satisfy above condition, and option D, which is e power minus n multiplied by u of n, satisfies this condition because in this case, sigma m equal to 1 to n mod f of m is less than or equal to b. From this, we see that the given system is BIBO stable for f of n is equal to e power minus n into u of n. Now, let us look into another problem in which there is a continuous time system which is given as y of t is equal to 1 by t integral t minus t by 2 to t plus t by 2 x of tau d tau where t belongs to r plus. We have to find if the system is linear, time invariant, causal, stable, and memoryless. We see that the given system satisfies superposition principle, that is the linear combination of inputs gives linear combination of outputs. From this we can show that the given system is linear. Also we can show that y of t minus t naught, which is delayed version of output, is equal to 1 by t integral t minus t naught minus t by 2 to t minus t naught plus t by 2 x of tau d tau, and output due to delayed version of input is equal to transformation of x of t minus t naught is equal to 1 by t integral t minus t by 2 to t plus t by 2 x of tau minus t naught d tau. Substitute tau minus t naught is equal to p. From this we can show that d tau will be equal to dp. When tau is t, we can, sorry, when tau is t minus t by 2, we can show that p is t minus t naught minus t by 2. Similarly, when tau is t plus t by 2, we can show that p is equal to t minus t naught plus t by 2. From this, we can show that this is equal to 1 by t integral t minus t naught minus t by 2 to t minus t naught plus t by 2 x of p dp. This is equal to y of t minus t naught. From this, we see that the output due to delayed version of input is equal to the delayed version of output. From this, we see that the given system is time invariant. Also, we see that for the given system, the output y of t depends on future values of x of t. From this, we see that the given system is non-causal and hence the system has memory as it doesn't just depend on present value of x of t. Also, we can say that the given system, sorry, also to prove the stability of the given system, let us assume that the input is bounded, that is mod of x of t is less than or equal to bx. From this, we can show that mod of y of t is equal to mod of 1 by t integral t minus t by 2 to t plus t by 2 x of tau d tau. So this is less than or equal to 1 by t integral t minus t by 2 to t plus t by 2 mod of x of tau d tau. We know that as the input is bounded, mod of x of t is less than or equal to bx. From this, we can show that mod of y of t is less than or equal to a times bx, where a is less than or equal to 1, or rather say 0 less than or equal to a less than or equal to 1. So from this, we see that the output mod y of t is less than or equal to by. So from this we see that the output is also bounded. So the given system is stable in BIBO sense. From this we see that the given system is linear, time invariant, non-causal, and it is not memoryless, rather say it has memory, and is stable in BIBO sense. Now let us consider a signal x of n is equal to e power j pi by 3n. We have to find if this signal is energy signal or power signal. So we can see that the given signal x of n is equal to e power j pi by 3 n can be written as e power j 2 pi by 6 n. From this we see that the x of n is periodic with a period of n is equal to 6. As the signal is periodic, we see that the signal is power signal and it is not energy signal. So the given signal x of n is equal to e power j pi by 3n is power signal but not energy signal. Now there is a system that is given as y of t is equal to x of t minus 2 plus x of t plus 4. We have to find if this system is linear, time invariant, causal, and stable and memoryless. We see that the given system satisfies superposition principle. From this, we can see that the given system is linear. Also, we can prove that the delayed version of output, that is y of t minus t naught, is equal to output due to delayed version of input. From this, we can say that the given system is time invariant. Thus, output at any point of time, that is y of t, depends on past x of t, that is x of t minus 2, and future x of t, that is x of t plus 4. From this, we see that the given system is non-causal and it has memory. Also, by assuming that the input is bounded, that is mod of x of t is less than or equal to bx, we can show that mod of y of t is less than or equal to mod of x of t minus 2 plus mod of x of t minus 4, which is further less than or equal to 2 times bx, as each of x of t minus 2 and x of t plus 4 are bounded. So from this we see that if the input is bounded, the output is also bounded. From this we can say that the system is stable in BIBO sense. From this we see that the given system is linear, time invariant, non-causal, and has memory, and also the system is stable in BIBO sense.